In this video, I'm going to take a look at how we take the derivative of an expression that consists of a product of two functions. The product rule is a fairly straightforward rule in that you take the derivative of the first term here, and that involves the chain rule, 5 times this to the fourth, times the derivative of what's inside, times the second. So this is the derivative of the first times the second expression, plus the reverse, which is the first expression times the derivative of the second. You see the 3 comes down, this drops to a 2, and then the derivative of what's inside. So this is the chain rule operating on both the first term and the second. Now, part of the problem here is factoring this out. You see, in this line I've taken the 2x and the 5, just written it as 10x out here just to clean it up a little bit. And the 3 and the 6 becomes the 18 here. Now what happens in all cases like this, you see you've got x squared plus 3 to the fourth here, and there it's to the fifth. 6x plus 1 to the third and to the second. Now if you take out a common factor, I'm not going to worry about the 18 and the 10 at this point, but you see if I take out the x squared plus 3 to the fourth and the 6x plus 1 squared, all I've got left is this. This always cleans up very nicely because these powers are only 1 apart. So for example, if I take out 6x plus 1 squared, all I'm left here with is 6x plus 1. And the same thing happens over here when I take out the lower power, which is x squared plus 3 to the fourth, just leaves one of those inside. So that always cleans up very nicely, and then all we have to do is multiply in here and gather up like terms, and that's it. If the teacher says just take the derivative and do not simplify, you probably just stop at this line right here. But if they want it simplified, it's necessary to take out the common factors. Before I do the next one, I just want to say a couple of things about common factors. Something like this you've been doing since very early algebra. If you take out a squared, this drops to a to the third. But something you probably haven't done before is a situation like this where I've got a to the negative 2. If I take that out, this actually increases to a to the 7th, because when I subtract the negative 2 from the 5, I get a to the 7. What you're really doing there is getting a common denominator, because this a squared could go under both of those. And where you're going to encounter this is when you're using the product rule and you're operating on a square root, and the square root is written to the half. It's going to drop to the negative a half when you take the derivative. And when you take that a to the negative a half out, this a increases to a 1. So once again, when you're simplifying, things will always simplify quite nicely in the bracket where the terms are remaining. Now here's an example of that right here. Again, this is the product rule because it's 3x to the fourth, that's the first term, times the square root of x plus 5. Now I'm going to rewrite that. I want it to the half rather than using a root sign, so I can use my power rule on this. Once again, it's the derivative of the first. The derivative of the first is very simple. That's just the 12x cubed here, times the second, plus the first times the derivative of the second. I wrote a 1 there because the derivative of what's inside is just 1. You don't have to write that, but I'm just emphasizing that I thought about what the derivative was in there. Now, when I take out x plus 5 to the negative a half, this thing increases to a 1, and I've still got my 12x cubed there. And removing it from here, I've just got the 3 over 2, I've just combined that. 3 times a half is 3 over 2, x to the fourth. So as I mentioned before, once you take out the common factor, this should clean up very nicely inside. I just multiplied this out. In order to make life a little bit easier when I go to simplify, what I did was I added the 12x to the fourth and the 3 halves x to the fourth. That gave me 27 halves. And just for convenience, I wrote the 60 as 120 over 2 so that I could take that half out, and then there are no further changes. Actually, I took out an x to the third as well and brought that out here. And if you want to rewrite this the way we started out, this this expression to the negative a half becomes the root on the bottom. Now, I want to look at one more example, and I'm going to look at this in 2 different ways. This is a root times a root, square root times a square root. I could write a square root over the whole thing, and that's what I'm going to do the second time, just to show you the difference in the approach. Once again, I write the roots to the half. This is to the 3 halves because I have the power 3 there. And this is what it looks like when I take the derivative of the first, that's the derivative of the first using the chain rule, times the second, plus the first times the derivative of the second, again using the chain rule. Now, when I take out common factors, you see the 3x minus 1 is to the 3 halves and to the half. So I'm going to take it out to the half. And with these terms, I'm going to take it out to the negative a half. So what happens is, I also took out the half too. I just wanted to get rid of, there's a 2 on the bottom of this and on the bottom of that. So I just took it out. This is what this looks like once you get those common factors out. That negative 2 is from here. The 3x minus 1 dropped from 3 halves to 1, and that was taken out. And over here, the 3x minus 1 to the half was taken out, and this increased to a 1. So this should always clean up very nicely inside. I wrote the 3 times 3 as a 9 here. And then multiplied out what's on the inside, just distributed the negative 2 and the 9. And then when I rewrote it, I simplified this square bracket here. This root ends up on top. That 2 is on the bottom, and that root is also on the bottom. Now, what I'm going to do is I'm going to do the same question, but instead of writing it as a root times a root, I'm going to put the root sign over the whole expression. And when I do that, instead of writing the root sign, I wrote it to the half because that's the same as square root. I brought that half down. You see, I'm working at this as now a chain rule with a product inside. So the first step is I bring the half down. That lowers to negative a half. And then I operate on the inside with the product rule. The product rule being the derivative of this, which is negative 2, times the second, plus the first term times the derivative of the second. That's just the chain rule operating on that. I then brought the negative a half onto each of these, so that becomes negative a half. This becomes negative 3 halves because you multiply those. And on the inside here, I took out a common factor of 3x minus 1 squared. So that reduces to a 1, and this is gone. I just have the 9 and the 5 minus 2x. Tidied up what was inside by distributing this. Brought this times, you see these two are the same. So when you multiply and the bases are the same, you add the exponents. So I'm adding 4 halves to negative 3 halves, which gives me 1 half there. And once I tidy that up, I have the same answer as I had when I did this the first time. So you can take your choice when you see a question like that. If you have a root times a root, you can either put the root sign over the whole thing and do it as a chain rule with a product inside, or you can start it with the product rule and then involve the chain rule with it.